Johannes, thank you very much indeed for joining us today. It's a great honour, a great pleasure that you've joined us as part of the Microsoft Research family. Before I ask you about your new role in Microsoft Research, perhaps you could first of all just share a few thoughts with us about your background and also how you came to join Microsoft.
Yeah, it's an interesting story because I actually joined Microsoft twice. So I was on the faculty at Cornell University, but I was also part of a startup in 2000, from 2005 to 2008. The startup was in the area of enterprise search called Fast Search and Transfer. And I was on a sabbatical at the startup from 2007 to 2008, when actually the startup was acquired by Microsoft. And so for a few months, I actually had a blue badge and was already at Microsoft. But then I went back to Cornell. And then in about 2012, 2013, we had another idea, namely the idea that um, search used to be, or enterprise search used to be signal poor as compared to internet search. But now with all of the search infrastructure and all of Office 365 moving to the cloud, we actually now have a ton of signals across, all of our customers. So, we're together now here in this meeting and we talk to each other. That's a signal that the two of us work together. Maybe I've quoted a document that you then continue to work on. That means we're working together. So actually, we can now use all of these signals to make enterprise much better, and then to build really other interesting applications on top of these signals. When we called that signal store the Office Graph, then it became the Microsoft Graph. So I joined in 2013 to build that here at Microsoft, and it was again first a sabbatical, but then I liked it here so much that I stayed on.
That's great. And so you now have quite a bit of experience in Microsoft Office. So tell us a bit about the impact on Microsoft Teams of having so many people now working from home.
Yeah, so after building the Office Graph and our application Delve on top of it, I had the privilege of working on Teams, and Teams was basically like a small startup within Microsoft. We moved really fast, and also it's completely built on Azure. So when then COVID hit us in early this year, we were actually architected in such a way such we could very easily scale. And the number of minutes that users spend in meetings, has become one of the dominant workloads in Microsoft Teams, has increased fivefold. So we started out, beginning of March, maybe with about 560 million minutes per day. And we've seen then later about 2.7 billion minutes per day. So it's about a fivefold increase. We've seen, days where we had more than 200 million participants. So just the scale during that time was just really amazing. And it was really great collaboration across Azure and E&D at that time. We also introduced new features that came both from the education space, such as attendance reports and other features, because we saw that we had now meetings with many, many more people and everybody was online, such as raising a hand. And we've looked at some of the data, and all of this is of course done with the right privacy controls, how people are using Teams. And we have seen that the average time that a person first used Team until the last use of Team each day increased by over an hour. Now, you could say, well, people don't have to commute anymore, but it doesn't necessarily mean that people are working more hours per day, but rather that they may be breaking the day up into, in a way that works for their personal productivity or make some space for obligations outside of work, such as looking after family or other things.
It was great to see this huge increase in the use of Microsoft Teams. And I think also a great honour to be able to serve people in this way by having that technology at just a time when people really need it. So perhaps we could turn now to your new role. We're delighted that you've joined Microsoft Research. I know you've only been in role a very short time, but can you tell us a little bit about the new role and what it will involve?
Yeah, so I'm in the role now for about 4 weeks, and it's really a privilege to be here. I mean, there's so many amazing people. There's really a huge breadth of research going on, and you'll see this, throughout this conference as well. Um, so I think what it can bring to the role is that I have seen the different parts of research, both at a university and now I'm experiencing it here at Microsoft Research. But I also bring with it a good understanding of what it means to be both in a startup as well as in a product team. So especially here in the last 7 years while I was at Microsoft, I've gained a deep understanding and a lot of empathy of what it means to ship products and how to scale software development to hundreds of engineers, how to think when you're in a product group, when you have to develop new features, when you have to talk to customers. And what are the challenges in working with also existing systems? Because every new system that you build here at Microsoft often has some legacy components to it, and you need to bring these legacy components then into the new world. So I hope to leverage this breadth of knowledge both from the research side as well as from the Microsoft internal side here in my new role.
So our focus here, of course, is on machine learning. So what are your thoughts on the role that machine learning could play in terms of productivity, tools and technology?
Yeah, so there are quite a few interesting ideas. I think the first one, of course, is to look at the audio and video stack and look at where there's often a lot of old control theory, whether we can replace that with machine learning. We are recently we're about to ship noise suppression, where we basically take an old style Gaussian noise suppressor and replace it with machine learning, and the advances there are really amazing. And this is also a good example where machine learning research is playing a big role, but also the gap between the papers that were published and actually what can be shipped was really big. And so we had to do a lot more work to make the models more performant and also work for the large variety of noises that we actually see in practice. So basically the whole control plane, maybe even the data plane of the audio video stack can be replaced with machine learning, in my opinion. Second of all, there might be very interesting user-facing features. If you think right now we have a feature where I can raise my hand, but then people forget to take their hand down or when they're done speaking. So I think there's a lot of user-facing features where we can just ease the level of interaction through the subtle signals that we usually see when we talk with each other one-on-one or in a physical setting that we don't really have in a virtual setting yet here at all.
Yeah, I think it's really interesting, isn't it, to see just how ubiquitous machine learning is becoming, and as you say, how many of these sort of more traditional problems are now being replaced with machine learning solutions that many times work better because they're tuned to the particular data or the particular environment in which they're actually used instead of being sort of general purpose. I think that is one of the big frontiers of machine learning these days. So your background is, in part at least, in databases. And are there particular research problems or challenges or opportunities that excite you right now at the intersection of databases and machine learning?
Yes, I'm really excited about that intersection. I mean, there's a lot of work already over the last years on systems for machine learning, and then also now applying machine learning to systems. And I think especially in the latter area, there are a lot of components in database systems that are really ripe to be replaced with machine learning. One example, of course, are small components such as selectivity estimation, where there's been a lot of work on building better cost models, and there's been a lot of work starting with histograms all the way up to random projections, up to very sophisticated sampling techniques, how to do better selectivity estimation for complex queries, and also not only selectivity estimation, but then really query costing. That is clearly a component that could be significant and enhanced with machine learning. But then there are other things like if I look at query optimization in general. Right now, we sort of componentize the query optimizer into different parts like selectivity estimation or costing, and then search space enumeration, because that's how we as humans, in a way, decompose the problem. But maybe what we can do is we can take a whole query optimizer and just learn both search space enumeration as well as costing in one big swoop. And there's actually really a lot of research that needs to be done because the state of the database changes over time. The query workload changes over time. How does the system adapt to this? What does it mean at the beginning now to learn a model, and how does the model adapt over time? So that is really one big area, sort of looking at the control plane of a database system and seeing how we can replace that with models. And then there's a whole other question of whether we can even take some parts of the data plane and replace that with models. There's been some recent work where we also did some work on learned indices, where you can take an index and replace it with a model. Basically, an index takes a key and then tells you where, conceptually in an array, the key is located. And you can think of actually approximating exactly that lookup with a model. And there's been some recent interest in this work here. In addition, you could think about code generation or even query operators that are being replaced with machine learned versions of them that are much more efficient. And the idea is that they could be much more efficient because they could be much more tuned to the actual instance of the database system. So in a way, the database system that we have right now is optimized for over all possible instances of a database system, Whereas if we create instance optimized database systems that may be much more performant and have much lower cost of ownership and much lower carbon footprint than a general database system.
Thanks, Johannes. That's really interesting. I mean, there's no shortage there of fascinating challenges to work on from a research point of view, and just incredible opportunities to deploy this technology in ever broader applications. I think it's an amazing time to be in the field of machine learning. I'd like to ask you one last question, if I may, which is really for the benefit of the graduate students who are watching today. Do you have any particular advice for them?
Yeah, I mean, one of the things I actually really miss being here at Microsoft is working with grad students. This is actually I think working with the grad students, the privilege of working with all the amazing students at Cornell was really one of the highlights of my career. So first of all, to all the students, congratulations. You're pursuing a PhD in one of the most exciting and fast-moving fields of computer science, and also a field where advances have great applications and potentially great benefits to society. And these applications, I mean, I see them every day at Microsoft are real. They might be for solving global climate issues, for health, where we can use machine learning to discover drugs and improve the health of people and communities around the world. For accessibility, we can use machine learning to amplify the human capabilities of more than 1 billion people globally who have a disability. Or for justice, in the case of studying bias in the human decision-making or fighting misinformation. And what is also exciting these days is that the cycle between doing research and then seeing its impact in especially the area of machine learning these days has become so short. So you develop a new algorithm, a new method, and a better model. And really within the next weeks after publishing it, it goes out and reduces the energy, let's say, of an Azure data center by millions of dollars a year and reduces our global carbon footprint. Or you may find a way to do better and cheaper noise suppression, and then you delight, really tens of millions of people around the world who are working from home or in conferences and who cannot concentrate because of noise from one of the participants. So my advice is just really dig both into the theory, but also into the practice, because that's what you do and that impacts all of us. And maybe my second piece of advice is that this sort of general advice I give to all PhDs, since they're not machine learning specific, is, you will do really great work in an area for a PhD. And research directions, they come and go, and they're superseded by new advances. So, whatever you specialized on in your PhD is important. But what's even more important is to learn what it means to do quality research and to acquire the taste of what are the right and important problems to solve, rather than the problems where you can write lots of papers about. And there's this beauty in doing research, in the exploration, in the problem solving, and the often undirected exploration. And you want to get that intuition and to understand which of these paths are more worthwhile to explore than others. And then, of course, the beauty of doing all of this here at Microsoft is that you could then see your research in the hands of millions of people right away.
Thanks, Janis. That's great advice. I'd certainly echo that comment about this being an amazing time to be in the field of machine learning. Even after 30 years in the field, I've not known a time as exciting as this or with as much opportunity. So thank you very much indeed for joining us. As I said, it's a tremendous privilege and honor and a great pleasure that you've joined us as part of the Microsoft Research family. And I just want to wish you every success in your new role. Thank you once again.
Thank you, Chris.